Find the degree of each monomial. Part A, 2x. The exponent of x is 1, so the degree of the monomial is 1. Part B, 3/4 x squared y squared. The exponent of x is 2 and the exponent of y is 2, so the degree of the monomial is 2 plus 2, or 4. Part C, 5x squared y. The exponent of x is 2 and the exponent of y is 1, so the degree of the monomial is 2 plus 1, or 3. Part D, -15. You can rewrite -15 as -15x to the 0th power, so the degree of the monomial is 0. Write -8 plus 9x to the 2nd power minus 2x in standard form. Identify the degree and leading coefficient of the polynomial. The polynomial is -8 plus 9x to the 2nd power minus 2x. A polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. So the polynomial in standard form is given by 9x to the 2nd power minus 2x minus 8. Notice that the greatest degree is 2, so the degree of the polynomial is 2. Also notice that the first term of the polynomial in standard form has a coefficient of 9, so the leading coefficient is 9. Write each polynomial in standard form. Identify the degree and classify each polynomial by the number of terms. Part A, 3 plus 7a to the 2nd power. A polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. So the polynomial in standard form is given by 7a to the 2nd power plus 3. Notice that the greatest degree is 2, so the degree of the polynomial is 2. Also notice that there are two terms, 7a to the 2nd power and positive 3, so the polynomial is a binomial. Part B, -b to the 2nd power plus 2b to the 4th power plus 6b. The polynomial in standard form is given by 2b to the 4th power minus b to the 2nd power plus 6b. Notice that the exponents of the terms decrease from left to right. The greatest degree is 4, so the degree of the polynomial is 4. Also notice that there are three terms, 2b to the 4th power negative b to the second power, and positive 6b. So the polynomial is a trinomial. Part C, 12c to the fifth power. Notice that the polynomial is already in standard form. The greatest degree is 5, so the degree of the polynomial is 5. Notice that there is one term, 12c to the fifth power, so the polynomial is a monomial. Find the sum. Part A. The quantity 3x squared plus 4x plus 3 plus the quantity 2x plus 5x squared plus 1. Align the like terms vertically and add. 3x squared plus 5x squared equals 8x squared. 4x plus 2x equals 6x. And 3 plus 1 equals 4. So the sum is 8x squared plus 6x plus 4. Part B. The quantity negative 5a squared plus a plus 2 plus the quantity 2a squared minus a minus 9. Group the like terms. Notice there are like terms negative 5a squared and 2a squared, positive a and positive 2 and negative 9. So the quantity negative 5a squared plus a plus 2 plus the quantity 2a squared minus a minus 9 equals the quantity negative 5a squared plus 2a squared plus the quantity a minus a plus the quantity 2 minus 9, which simplifies to negative 3a squared minus 7. So the sum is negative 3a squared minus 7. Find the difference. Part A. The quantity 3y squared plus 8 minus the quantity 6y squared plus 4y minus 2. Align like terms vertically and add. Rewrite the subtraction as addition by using the distributive property. Multiply each term in the second polynomial by negative 1 to rewrite the second polynomial as negative 6y squared minus 4y plus 2. 3y squared plus negative 6y squared equals negative 3y squared. 0 plus negative 4y equals negative 4y, and 8 plus 2 equals 10. So the difference is negative 3y squared minus 4y plus 10. Part B. The quantity 12t squared plus 5t minus 7 minus the quantity negative 4t squared plus 3t minus 1. First use the distributive property. Multiply each term in the second polynomial by negative 1 to rewrite the expression as 12t squared plus 5t minus 7 plus 4t squared minus 3t plus 1. Next, group like terms. Notice there are like terms 12t squared and 4t squared, 5t and negative 3t, and negative 7 and 1. So the expression simplifies to the quantity 12t squared plus 4t squared plus the quantity 5t minus 3t plus the quantity negative 7 plus 1, which simplifies to 16t squared plus 2t minus 6. So the difference is 16t squared plus 2t minus 6. A penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 75 feet. The polynomials represent the heights in feet of the objects after t seconds. Part A. Write a polynomial that represents the distance between the penny and the paintbrush after t seconds. To find the distance between the objects after t seconds, subtract the polynomials. Rewrite the subtraction as addition by using the distributive property. Multiply each term of the polynomial that represents the height of the paintbrush by negative 1 to rewrite the polynomial as 16t squared minus 75. Negative 16t squared plus 16t squared equals 0. Negative 40t plus 0 equals negative 40t. And 200 plus negative 75 equals 125. So the polynomial negative 40t plus 125 represents the distance between the objects after t seconds. Part B. Interpret the coefficients of the polynomial in Part A. When t equals 0, the distance between the objects is negative 40 times 0 plus 125, which equals 125 feet. So the constant term 125 represents the distance between the penny and the paintbrush when both objects begin to fall. As the value of t increases by 1, the value of negative 40t plus 125 decreases by 40. This means that the objects become 40 feet closer to each other each second. So negative 40 represents the amount that the distance between the objects changes each second.